So today we are going to discuss about the PN junction diode voltage current characteristics. Okay, the below one shows the circuit for the forward bias and reverse bias. Okay, so here we are going to observe the voltage current characteristics of forward bias as well as reverse bias. Okay, now for that the components required are the breadboard and this 1 kilo ohm resistance, PN junction diode, RPS, voltmeter, milliammeter, as well as microammeter. These are the components required. Right now we are doing the forward bias, so that's why our requirement is milliammeter. Okay. Now here I am giving this connection, this circuit connection. Now here first we need to connect the 1 kilo ohm resistance anywhere on the breadboard. Okay, thereafter 1 kilo ohm second hand is connected to the PN junction diode anode. Now how to identify the anode and cathode for the PN junction diode? So here this silver color indicates the cathode, and this one indicates the anode. Okay, now this anode connected to 1 kilo ohm resistance second hand vertically on the same place. Thereafter second hand you can place anywhere on this, that means cathode terminal place anywhere on this breadboard. Okay, now 1 kilo ohm resistance, thereafter anode terminal is connected, cathode terminal is connected somewhere. Okay, now if you observe the circuit from cathode to ammeter positive, now this is my ammeter positive to the cathode is connected. Ammeter negative you can place anywhere on the breadboard. Okay, thereafter if you observe the circuit, RPS positive is connected to the 1 kilo ohm first end. Now this is my RPS positive, this is connected to the 1 kilo ohm first end vertically on the same place. 1 kilo ohm first end vertically on the same place. Okay, thereafter we need to connect the RPS negative to the ammeter negative or ground, ammeter negative. Okay, where is ammeter negative? So here this is my ammeter negative vertically on the same place. Either you can connect vertical on the same place, otherwise you can connect ground, no problem, both are same. Okay, now we need to connect the voltmeter. Okay, now here voltmeter is in parallel with this PN junction diode. Okay, now positive is connected to the anode, negative is connected to the cathode. Now here this is my positive of my voltmeter connected to the anode vertically on the same line, anode. Okay, thereafter this is my negative of my voltmeter, this is connected to the cathode vertically on the same node, Okay, now this forward bias connection is completed. Now we need to apply the supply voltage. Thereafter we need to verify the voltage and current. Okay, now for that I am going to switch on the supply. Now by varying the supply voltage we need to note down these two, voltmeter reading as well as ammeter reading. Now sir I am varying the voltage. When it is 0.1, there is no movement of charge carriers, so that is the reason why the current is 0. Similarly, if you increase to the 0.2, 0.3, also it is 0. Why? Because the barrier potential is greater than this voltage across the diode, so that's why the current is 0. Okay, now here again I am increasing 0.4, again it is 0, again 0.5. When I am increasing to 0.5, the current starts increasing. Okay, that means the barrier potential is lesser than this voltage, so that is the reason why the current starts increasing. Now here again I am increasing my supply voltage as well as this voltage across the diode, the current is increasing. See here how it is increasing. See here there is a sudden increase in the current. At 0.6 it is increasing from some 0.5, 0.4 to directly 4.4, sudden increase in the current. Okay, now see that is what we need to observe. When you increase the voltage across the diode, the current is increased up to 30.5. This is what voltage versus current. Voltage, current characteristics of your forward bias PN junction diode. Okay, now we need to connect the reverse bias. For that I am decreasing the total supply voltage as well as I am going to switch off the supply. Thereafter I need to connect the reverse bias connection. Okay, I am removing all these connections. Okay, for reverse bias connection, our requirement is microammeter. Why? Because in the case of reverse bias, the current induced is due to the minority charge carriers. So that's why we are going to use the microammeter instead of milliammeter. Whereas in the case of odd bias, we are using the milliammeter. Why? Because the current is due to the majority charge carriers. See here. Now for this reverse bias, I am using this microammeter. Okay. Now here these two are the same connection. There is no change in these two connections. Resistance as well as the diode position is same position. Okay. Now only the negative. Here RPS negative is connected to the anode, whereas previously RPS positive is connected to the anode, whereas here RPS negative is connected to the anode. Okay. Now here this is my RPS negative. So this is my RPS negative. Now RPS negative is connected to the resistor first 10, 1 kilo first 10. It is connected. Thereafter, if you observe here, cathode terminal is connected to the ammeter positive. Now this is my ammeter positive. This is my ammeter positive. It is connected to the cathode. Connected to the cathode. Thereafter, negative you can place anywhere on the breadboard. Negative anywhere on the breadboard. Okay. Thereafter, if you observe here,